Sweetness Without Calories, The Neurobiology of Non-calorific Sweeteners by AZLAN ADNAN, MA. Friday, 21st of November 2025. Introduction. Non-calorific sweeteners offer sweetness without energy, yet their biological effects reach far beyond taste. Many diabetics use them daily, but few understand how deeply they interact with the brain, gut, and pancreas. Sweetness begins with specialized T1R2, T1R3 receptors on the tongue. These receptors also exist in the gut and even on pancreatic beta cells. They respond to sugars, sugar alcohols, and non-calorific sweeteners. The body therefore registers sweetness even when no calories arrive. Types of non-calorific sweeteners. Common examples include sucralose, aspartame, acesulfame K, saccharin, stevia, monk fruit extract, and erythritol. Newer options such as allulose, inulin, FOS, and GOS are also becoming popular. Each sweetener behaves differently in the body. Their metabolic effects vary widely. Neuroscience of sweetness. When sweetness touches the tongue, signals travel through cranial nerves into the nucleus tractus solitarius, NTS. The NTS is located in the brainstem. From the NTS, signals reach reward centers such as the ventral tegmental area, VTA, and nucleus accumbens, NAC. These regions trigger a dopamine response that evolved to identify calorie-rich foods. Non-calorific sweeteners break the link between sweetness and energy. This mismatch may alter reward processing, cravings, and appetite regulation. Gut sweet receptors and hormonal signaling. Sweet receptors in the gut influence hormones such as GLP-1 and GIP. These hormones help coordinate insulin release and glucose control. Some sweeteners can trigger a modest cephalic phase insulin response. This is a small anticipatory insulin release before any glucose reaches the bloodstream. Clinical concerns. Dr. Michael Greger. Dr. Michael Greger, a physician and author known for evidence-based nutrition advocacy, highlights potential risks. He warns that repeated sweetness without sugar may place unnecessary stress on beta cells. He suggests the body expects glucose whenever sweetness is detected. When glucose fails to arrive, the pancreas may release insulin again and again. This could theoretically fatigue beta cells over time. Human evidence, however, remains limited and inconclusive. Dopamine and addiction. Prof. Robert Lustig. Prof. Robert Lustig is professor of pediatric endocrinology at the University of California, San Francisco. He is widely recognized for his work on sugar addiction and metabolic disease. Lustig warns that intense sweetness can overstimulate dopamine pathways. This may increase cravings and encourage addictive eating behaviors. He also notes that saccharin and sucralose can disturb the gut microbiome. He believes metabolic disruption may occur even without direct beta cell injury. Whole food perspective. Prof. Emeritus T. Colin Campbell. Prof. Emeritus T. Colin Campbell of Cornell University founded the T. Colin Campbell Center for Nutrition Studies. He is widely regarded as America's leading nutritional biochemist and authored the China study, Whole, and the Future of Nutrition. Campbell argues that artificial sweeteners perpetuate a taste for hypersweet foods. Traditional plant-based diets linked with excellent health contain very few such products. He encourages a shift toward whole, unprocessed plant foods. This shift lowers sweetness preference naturally and sustainably. Dietetic view. Brenda Davis, RD Brenda Davis, RD, is a leading plant-based dietitian and respected nutrition researcher. She acknowledges that sweeteners can reduce sugar intake for diabetics. Davis emphasizes that sweeteners vary greatly in their metabolic effects. She prefers stevia, monk fruit, and erythritol, while advising caution with older artificial compounds. She stresses that diet quality ultimately matters more than sweetener choice. Sweeteners offer benefits only when used sparingly within a whole food eating pattern. Non-caloric sweeteners and the microbiome. Prof. Emran Mayer. Prof. Emran Mayer is a gastroenterologist and neuroscientist known for his work on the gut-brain axis. He highlights that non-calorific sweeteners are not biologically inert and can meaningfully influence gut microbe interactions. Mayer notes that several artificial sweeteners can alter microbial metabolic pathways. He warns that this may shift short-chain fatty acid production, change energy harvesting, and contribute to low-grade inflammation originating in the gut. He also suggests that these microbial shifts may affect brain signaling pathways linked to appetite and mood. For this reason, he recommends limiting non-nutritive sweeteners and prioritizing whole food dietary patterns that support a stable gut-brain ecosystem. Microbiome Insights. Prof. Tim Spector. Prof. Tim Spector is professor of genetic epidemiology at King's College London and co-founder of Zoe. He studies how diet influences the gut microbiome. Spector warns that certain sweeteners can alter gut microbial composition. These changes may affect glucose tolerance and metabolic resilience. He considers occasional use safe, but he advises against daily intake through ultra-processed foods. Non-caloric sweeteners and microbial ecology. Doctors Erica and Justin Sonnenberg. Doctors Erica and Justin Sonnenberg, microbiome researchers at Stanford University, emphasize that the gut ecosystem is highly sensitive to modern dietary additives. They caution that non-calorific sweeteners can shift microbial composition in ways that reduce diversity and resilience. They highlight that several sweeteners may promote the growth of opportunistic bacteria while suppressing fiber-loving species. This imbalance can impair mucus layer integrity, interfere with fermentation pathways, and increase inflammatory signaling in the gut. The Sonnenbergs also note that long-term reliance on ultra-processed foods and sweeteners may starve the microbiota of its preferred substrates. For this reason, they advocate a diet rich in diverse plant fibers and fermented foods to counteract microbial stressors introduced by artificial sweeteners. Sugar alcohols and emerging sweeteners. Sugar alcohols behave very differently from each other. Maltitol raises blood glucose significantly, while erythritol and xylitol have minimal effects. Newer prebiotic sweeteners such as inulin, FOS, and GOS are mildly sweet. They also feed beneficial gut bacteria. Allulose is particularly interesting because it is very low calorie and non-glycemic. Its long-term effects, however, still require research. Safety regulation and dosage. EFSA, FDA, and WHO classify most sweeteners as safe at normal intake levels. They also acknowledge gaps in long-term human data. Dose matters enormously. Many adverse effects appear only at high or chronic intake. Sweeteners are helpful tools, but they are not biologically neutral. Their impact depends on type, amount, and overall diet. Practical guidance for diabetics. For diabetics, moderation remains the safest approach. Sweeteners reduce sugar intake, but do not eliminate cravings for sweetness. They can also reinforce a psychological dependence on sweet flavors. This may undermine long-term dietary change. Conclusion. For individuals living with diabetes, it is wise not to begin habitual use of non-calorific sweeteners. They can be habit-forming, and long-term use may disrupt metabolic signaling in ways that increase reliance on exogenous insulin injections. A more sustainable solution is to slowly reduce the desire for intense sweetness. This reflects the lifelong work of Prof. Emeritus T. Colin Campbell, who advocates returning to whole food, plant-based nutrition. Such an approach naturally lowers sweetness preference. It also improves metabolic stability, insulin sensitivity, and overall well-being. This path offers diabetics a grounded, hopeful way forward. A whole food lifestyle can rebuild metabolic health and restore a calmer, more natural relationship with food.
An invitation, International Day of Persons with Disabilities, Wednesday, 3rd December 2025, 1200 to 14:30 hours. Venue MAB Canteen, Malaysian Association for the Blind, MAB Complex. Address Jalan Tebing, off Jalan Tun Sambanthan, 4 Brickfields, 50470 Kuala Lumpur. To commemorate the International Day of Persons with Disabilities this year, I am hosting an informal roundtable luncheon to discuss universal design. Panelists will include my friends with various disabilities, including vision impairment, physical disability, and hearing impairment, as well as my architect and lawyer friends. This informal discussion on universal design will be of interest to architects, town planners, civil engineers, quantity surveyors, advocates for accessibility and inclusivity, persons with disabilities, PWD, as well as caregivers and students of architecture and design. For a totally immersive experience, all sighted persons will be blindfolded throughout the event. Lunch will consist of a whole food, plant-based WFPB menu curated by me. This event is also open to members of the public. Attendance is by donation for able-bodied and sighted persons. Hopefully, your contribution will cover the cost of your lunch, as well as that of a PWD. Seating is limited, and at the moment there are 15 places left. To confirm your attendance, please make your voluntary contribution by scanning the QR code. If you're unable to attend but wish to support this event, feel free to make a small donation, not more than 5% of your monthly income. Any excess funds will go towards ongoing treatments to restore my vision. We will have a fruitful and meaningful discussion that will raise awareness of the need for universal design for PWD. Universal design. For background information on universal design, I have made several videos. Links are in the video description below. AZLAN ADNAN MA, VIP founder, Green Party of Malaysia.
International Day of Persons with Disabilities, Wednesday, 3rd of December 2025. Every year, 3rd of December is officially recognized by the United Nations as the International Day of Persons with Disabilities. It has been observed globally since its proclamation in 1992 under UN General Assembly Resolution 4730. The day promotes understanding of disability issues, supports the dignity, rights, and well-being of persons with disabilities, and raises awareness of the importance of inclusion in all spheres of life: political, social, economic, and cultural.
don't forget to hit that subscribe button to show your support. Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.